Hi, my name is Uche, and I work with the Professor Andres Shasland's group in UCL, London. Just a little background about myself. I had my degree from the Bello University in Nigeria, and my master's in the University of Pittsburgh in the United States. I worked basically using UPL CMS to quantify biomarkers for traumatic brain injury. And I'm currently in the final year of my PhD at UCL in London. My role? So I'm designing some particles, GSPQ specifically, and designing them with varied properties to help in facilitating delivery of oral drugs. I'm also working with, did some work with work package 3. I used cell models, Caco2 cells, and tested delivery of drugs across. I'm also working with the work package 4, where I'm using confocal microscopy to observe interactions with intestinal epithelium. Some of the questions I thought to answer is how do these nanoparticles interact with the intestinal epithelium? What's the nature of the interaction? And how does this interaction facilitate uptake of some of the loaded macromolecules? Some of the tools I've used, first to design or synthesize. I had to learn chemistry, polymer chemistry, to synthesize. And then to characterize, I had to use techniques like NMR, the GPC, DLS, TM, and ITC for thermodynamic characterization. I also had to learn how to conjugate fluorescent probes to these particles or the polymers, and testing for their mechanism of action. I've learned how to do cell biology, do toxicity assays, Caco2 cell monolayer. I've learned flow cytometry and a few other assays and skills. In vivo, I've had to be licensed to work with rodent models. So I've learned how to do oral gavage, in vivo drug administration, tissue processing, fluorescence staining, and confocal microscopy. These are a few of the skills or techniques I've had to use so far. Pardon the imaging. So just a little, sorry, I think it's just sort of distorted. I don't know why. Just a little bit of what I've observed from the results that I've had. So I designed these particles with specific structural modifications, and the goal is to have them have varied levels of modulation of the tight junctions. Obviously, there are concerns about whether you open up tight junctions and toxicities that come with that. So we've been able to design particles that could not open up the tight junctions, but still facilitate uptake, and those that can modulate tight junctions in a way that's quite comparable with something like C10, sodium caprate. And I've also been able to use confocal microscopy to show that some of these particles get taken up eventually. There's a lot more data on this, but it's just a little bit of what I've done. And I've talked a little bit about some of the skills I've learned and things I've learned. For me, I think it's quite holistic that you can start from chemistry, go in vitro, and go in vivo. And that gives me a wide range of skills and exposure and experience. I've also gotten very valuable skills, obviously, with the cell biology. But I think what's very key is collaborative research, being able to interact with people you don't know, being able to share your data with them, being able to receive samples from people you don't know, and having to work with your samples and have them trust that what you do with it is good. I think that can be challenging because you're compelled to give your best to whatever you're doing. I think that's a very key advantage. And obviously, being in a place like this where you get to present to people and have them listen to you, and that tests your ability to present, that's also something that I've gotten from working with transit. What will I be? Oh, some of my outputs. Well, I had a poster presentation at the last meeting in Cork. I also had an oral presentation. I've submitted an abstract for the AAPS conference in San Diego in November. I hope to be there. And my next steps, complete my PhD and see what opportunities there are out there in industry or in academia. Thank you.
Any questions? Okay, if not, we're going to move on.
Thank you.
Thank you.